Hello everyone, this is Snigdha Kakkad. This is my channel Accelerate AI Careers. Today's lead code problem we are going to solve is lead code 39 combination sum. It has been asked in Amazon and Microsoft interviews. It is one of the blind 75 problems. It's a really famous one. So let's look into it. We have been given an array of distinct integers. The array name is candidates and the target integer called target. We should return a list of all unique combinations which might sum up to this value target. So you may return combination in any order, but there should not be any repetition in terms of the combinations. The same number may be chosen from the candidates more than once. It can be chosen unlimited number of times as it has been mentioned. Two combinations are unique. The frequency of at least one of those chosen numbers is different. But if the frequency is also same and just the order is different, then they are considered as the same combination. And the same combination cannot repeat. So we have to generate as many unique combinations we can. So the test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. So let's look into this question. Okay. So let me explain you the most naive approach which we could take when we are dealing with such a question. So let's take this array which has been given here in example 3, 7. This is your candidate. And what's your target? Your target is 7. So what would be the most naive approach if you try to solve this question as a novice? So when we try to solve this question as a novice, I might consider pick up a number set out of this array. Say I pick up 2 and see what all combinations 2 can lead. So 2 can lead 2, 3, can lead 2, 2, can lead 2, 6, can also lead to 2, 7. Then again, I would see what further, further combinations can happen. 2, 3, 2, could be 2, 3, could be 2, or it could be 6, 2, and so on. I'm not going further because I know 2, 6, 2 sums up to more than 7, which is more than target, so it is not one of the value. But do you see, I just picked 2 and started making combinations with 2 as a naive approach. And you see 2, 3, 2 is one combination and 2, 2, 3 is one combination. And they both are actually the same combination, just the order is different. You can of course get all the combinations which sum up to 7 by this way. But it would be a lot of time taking and you have to find out how to avoid the repetition of combinations with different orders. So like 2, 3, 2 and 2, 2, 3 are actually the same combination just in different order. So how to avoid it? What could be the other approach? So approach we are going to take for this question would be backtracking. So would be recursive approach, and let me explain to you how will we go about it. So how can we actually ensure that there is no repetition between two combinations? So I will always make decision. So say suppose when I'm talking about just digit 2 out of the combination or out of the candidate, either I can select or I can not select. If I'm not selecting 2, I'm taking an empty array. And if I'm taking an empty array, that means the further combinations which I make with it will not have 2. It will just have either 3 or 6 or 7. And the combinations which I make with 2 will have. So this will ensure that there is no repetition in terms of combinations with different orders. So now how will we make further combinations? When I'm talking with combinations further with 2, it could be 2, 2, or it could be 2, 20. That is, it could be anything but. So one would be like where you have 2 times 2 repeating, the other could be you have only 1, 2 repeating. And then further combination for this would be that you have 3 times 2 repeating, or you will have only 2 times 2 repeating, and the third value would be either 3 or 6 or 7, and so on. So now when you actually go further, you can have 3 times 2 and then 3, 6, 7, either of these. Say and the other value could be 2, 2, 2 and 6 and so on. This making of decision whether to include this digit at this stage or not whether to have this digit repeated only once or twice or thrice will ensure that it is not getting repeated in terms of combinations. So when you talk about unique combinations, you will have only one unique combination. There will not be any repetition because you are either taking that digit or you are not taking that digit. I hope that clarifies. So at each stage, you are making that decision and finding the last permutation. So this is like one decision you made whether to include 2 or not include 2. Same way the decision would be made whether to include 3 or not include 3, whether to include 6 or not include 6, whether to include 7 or not include 7. And based on that, you will have a lot of combinations. And in every stage, you will make that decision. So whenever you make that decision, you either include it or decide to duplicate it or have it more than one times, or you decide not to have it more than one time. And this goes on and on. So the time complexity would be, since you're making that decision and you always have two options coming up, either you select it or you don't select it. So you always have two choices to make. Now it will be raised to the power at least to the target. So at least you will be making 7 decisions. You can calculate this yourself with this example given to you, but this would be your time complexity or your. Now, hence we have discussed the approach. Let's see how we can implement it. So, say suppose I want to implement it. We'll first define an array result where I will be saving all my combinations, which is right now empty, of course. Now I will define a recursive function which I'm going to repeat again and again. Let us call it as DFS, which stands for depth first search. And what all variables do I need to consider there? So I will consider current index, which would be I. I will also consider current combination. Let me name it as current. And we'll also consider the total we have reached until now. Will be my variables here. Now, what would be my base case? My base case would be when my actual total value reaches the target. So, total is equal to target. That means you have achieved the right combination and you should append the result with that combination. So, result.append. And what would you append? You will append with current, but current combination is changing again and again. So, you will make a copy of it and save it. Okay. Now, there is nothing to return here. You have appended the current combination where the total summed up to target, and you have appended it to the result, and you can just return. Now, what would be the next condition? The next condition would be either your current pointer has reached to the length of the array, which is length of candidates, or your total has exceeded the target. If your total has exceeded the target, you need to backtrack, right? You cannot go ahead. So you need to exit immediately. So this is your second condition, which is your opt-out condition. Either you hit the length of the candidates array, you have went through the entire array, or your total exceeds the target. In both the cases, you just return. So now you will make two choices. Either you choose to include the current index value, or you choose to skip the current index value. Based on that, we will be calling DFS function recursively. Okay. So if I choose to include the current value, that means I will include the current candidates, this value to my current combination because I'm choosing to include it. And then I will call depth first search function. So my current index is I since I'm including it. Then I'm passing current where I have appended the current value candidates I. And I will pass total. But in total, I also need to add the current value. So this is one combination. The other decision I could make is that I choose to skip this value. If I choose to skip this value, then I need to pop it out of current because I already modified current combination and I had appended it with candidate side. So I need to modify current and pop the last value. And then I will call DFS. And since I'm choosing to skip the current value, so my index which will go is I plus 1 and current. And my total would be total. I don't need to add candidates I because I'm choosing to skip it. So this way you are making two decisions and getting all the combinations at the same time. And then finally, then what? After that, you have made all the decisions. You just need to call DFS from scratch. So when you will call, the index would be 0 because you're calling it in the beginning of the candidates array. your result would be an empty array because you have not appended any combination so far, and your total would also be 0. And finally, you can just return your result because it will have all the combinations which sum up to the target value appended to it. And that's the entire code, and the result is accepted. Let's submit it. And you can see the result here. So I hope the solution is good enough. I can quickly give you a brief scheme how we went about it. So every value in a particular candidate's array is a candidate. You can either choose to include it or choose to skip it. This will ensure that there is never a repetition of the same combination, just with different order. So you are ensuring always either you are including a value in a combination or not. Based on that, you are calling the DFS function recursively twice. And you have to modify the current combination on the basis of whether you are including the current candidate or you are not including the current candidate. And this way, you will be verifying all the combinations, and whenever the total equals the target value, you append that current combination to result. And finally, you return the result. I hope that clarifies. If you have any questions, mention in the comments. If you have a better approach to solve it, I would like to know that. Share it in the comments here. Let me know how you feel about my problem solving, and is there any problem specific you want to solve on LeetCode? I am happy to jump on that. Let me know. Thank you.